continue. Let's continue on verifying identities. And remember, we're trying to make the left look like the right. So we're taking, it's saying the cosecant of theta minus the sine of theta is equal to cosine of theta times cotangent of theta. The first thing that I'm going to do is write everything in terms of sines and cosines. So cosecant of theta is just 1 over sine theta minus the sine of theta, and that should be equal to the cosine of theta times cotangent of theta. Well, that's just cosine of theta over sine of theta using our identities. Now, to the left, I'm going to just make this a common or one whole fraction. That means that I'm going to use my common denominator sine of theta over here. So that means I have to multiply this sine theta over here by sine of theta over sine theta. We need to have a common denominator. So that means that I would end up with one big fraction with sine of theta in the denominator, but in the numerator, I would have 1 minus over here sine theta times sine theta, because remember this sine of theta is over a 1. I would end up with a sine squared theta. All right. And that's going to be equal to the right. Look at this. Cosine of theta times cosine of theta. That's just cosine squared theta over the sine of theta. All right, guys, looking at this, 1 minus sine squared theta over the sine of theta is equal to cosine squared theta over sine of theta. Now look, in the numerator, guys, from our Pythagorean theorem, we know that 1 minus sine squared theta is just cosine squared theta. So this whole numerator is equal to that. And I can sub that in. So I have cosine squared theta over sine of theta. That equals to cosine squared theta over sine of theta. My left looks like my right. I have verified this identity. There's nothing further that I have to do. It is done. As soon as I get the left looking like the right, it's verified.